All right. Let us discuss the question paper of today, that is JEE 2016, conducted today on 3rd of April. Overall, if you look at the paper, it is, I feel it is not of the level of IIT, because there are many questions which are just factual in nature. There is nothing in that to be said, especially on the semiconductors. They have asked 4 questions. That is very unpredictable. And fluid mechanics they haven't touched. So there is no question from fluid mechanics, as you can see. All right, let's get going and let us discuss. I have code F with me and I'll be discussing the problems. Okay, problem number 61. Let us understand what the problem says. 61. It is talking about a string of length 20 meter which is suspended from a rigid support. A short wave pulse is introduced at the lower end. It starts moving up the string. The time taken to reach the support will be equal to what? See, straight away when we read the problem, the concept should come to our mind. If I tell you that there is certain distance x involved and the wave has to travel this distance x, then what is the formula for velocity? You know, the formula of velocity of a wave on a stress string is root T by mu, where the T is tension and mu is mass per unit length. But here in this case, if you take the mass of this string to be m, then the tension will be varying from this point to this point. The tension will be 0 and the tension here will be mg. So we have to take an element. So let us take a small element here and let us call this small element dy, and let us say it is located at a distance y from here. So what will be the tension corresponding to this particular point? Obviously, mass per unit length we know. Mass per unit length is mu and this length is y, right? So what will be the weight corresponding to this section which will cause the tension here? That will be equal to mu y into g, because mu is mass per unit length, y is the length of this particular string with the tension. This has to be borne by this element. So mu y g. This will be the dt, the tension in this particular part, right? So this tension takes care of this particular thing. Now, if I'm talking about the time dt it would take to travel this small distance from here to here, so the distance here is dy, and the velocity, that velocity part will be equal to under root of t. T you have calculated mu y g divided by mu. So obviously you can lose mu with mu. So what do we get here? We get dt is equal to, take this term on the top, y to the power minus 1 by 2 of dy, okay, and you can take this term here 1 by root 10, and let us now put the integration here. See, the pulse starts from here. What is the value of y here? 0. It has to reach this point. So how much distance will travel? 20. So you will say, as pulse goes from 0 to 20, the time it takes will be 0 to t. So obviously now you can solve it yourself. 1 by root g, I have taken this to be 10. So there may be a slight variation there. Y minus 1 by 2, you know that will be equal to y to the power of 1 by 2 divided by 1 by 2. And then the limit of this is 0 to 20. So what do you get here? You get t equal to y to the power 1 by 2, that is equal to root 20 into 2 divided by root 10. So you can see the answer for this will be 2 root 2. 2 root 2, check out. The answer 2 root 2 is 2. So the correct answer for this particular problem will be 2. Is that okay? Fine. 62nd problem. 62nd problem, if you look at it, this is a problem from NCERT. Ditto. Without an iota of change, they have given you the problem. And the concept is very, very simple. A person is trying to lose weight, and what is he doing? He is lifting a mass. What is the mass he is lifting? 10 kg. And he is lifting it to what height? 1 meter. So if I lift a mass of 10 kg, what is the weight involved? 100 kg. 100 Newton rather. So 100 Newton of weight you are lifting to 1 meter, right? And you're doing it how many times? You're doing it 1000 times. Okay? So mgh corresponding to this, if you write the energy or the work that you will do, that will be equal to 10 to the power 5 of joule. I'm taking g to be 10, okay? So the question they have mentioned it to be 9.8, so I should have taken this to be 9.8. So I'm taking 10 so that the calculation I think will be simpler. Okay. Then they say that when you do this much of work in raising the mass and bringing it back, then in the process, the fat when it burns up, 3.8 into 10 to the power 7 joule of energy is burnt per kg. So what is the meaning of this? 3.7 into 10 to the power 7 joule per kg is the calorific value of fat. And if m amount of mass, let us say the fat burns, then the total energy release will be this much. But the conversion efficiency is 20%, so 0.2. So this is the total energy term that you are going to get. The kg here can be cancelled. So what are you getting here? You are getting 0.2 into 3.7 into 10 to the power of 7 joule, and corresponding to this multiplied by m should be equal to 10 to the power of 5, right? So what I can do is 3.7 here and 0.2 here, that will make it 100. So this 100, 10 to the power and 10 to the power 7 I can lose. So what do I get? I get m equal to, this is 1 by 2 into 37 kilogram. If I had to write it in gram, I can simply do 10 to the power minus 3 and write this to be 1000. So m becomes equal to 1000 divided by 37 into 2, that is 74, I believe, 76, right? 76. So 1000 by 76 into 10 to the power of minus 3. Go for the rough answer. 76 into 10 will be 760. So it will be 12.89 is the most appropriate answer, because it will be more than 10, and no more than 10 you have only one answer. So the correct answer for this will be third. This is problem number 62, right? Okay, let us talk about the next problem that is there. Okay, so I'll have to rub off this. 63rd problem. First, understand what is the problem trying to tell you. The problem is trying to tell you one thing, that is, there is a point mass m which moves along a uniform rough track PQR as shown in the figure. What are they trying to tell you? That you have a track out here, starts from here P, this point is Q, and when it reaches here, this point is R, right? And you release a mass m from here, and then this reaches this point and comes to rest. The second data that is given to you in this particular problem is that the energy is lost by the ball over the parts PQ and QR of the track are equal to each other. That is, whatever energy you lose here, the same amount of energy you lose in this section, right? Besides that, they are telling you one more thing, that is, no energy is lost when the particle changes the direction from PQ to QR. So that impact part, they are saying that you can ignore that. So let us start with the data and let us make two equations, two possible equations. First thing is telling you is, it starts from here and it comes to rest here. So now two things are clear. What is the kinetic energy here? 0. What is the kinetic energy here? 0. So what is the change in the kinetic energy? 0. What is work energy theorem? Work energy theorem says total change in kinetic energy is equal to work done by all the forces. How many forces are doing the work here? You will say there is a gravity involved in this particular problem. This height is given to you, that is 2 meters. Your angle given, that is theta, is given to you as 30 degrees. So let us get going. What is the work done by the gravity? It has come from here to here. I can see the work done by the gravity is mgh. What is the work done by the friction from here to here? You will say, fine, this will be minus of mu mg cos theta into this particular distance here. Now, if I call this height as h and call this distance as s, then you will agree with me that sine theta is equal to s over h. So whenever, this will be h over s. So if I had to replace this s, I can replace this by h by sine of theta. Okay, so mu mg cos theta, that will be the force that will act in this direction. The particle is moving in this direction, and what is the displacement part? H by sine of theta. Now, the particle comes from here to here. What is the force acting here? Obviously the friction. Friction is mu mg in the backward direction. So minus mu mg, and the displacement here to here they have given you as x. So the displacement here is x, but all this leads to 0. If all this leads to 0, I say get rid of mg, get rid of mg, get rid of mg. So what are you left with? You are left with h minus mu into h. H is given to you in the problem, that is 2. Okay, cos theta by sin theta, you know, is cot theta. So this is cot of 30 degree, and this is minus mu x is equal to 0. So this is our equation here. The second equation involved will be that you start from here and come to this particular point. The energy lost here. Why do you lose energy? Because the friction is doing the work. Okay, how much work is done by the friction from here to here? That is responsible for the loss of energy. So that will be equal to mu mg cosine of theta into the displacement part that you know from here is h over sine of theta. This lost energy is equal to whatever is lost here. Again, the work done by the friction leads to the loss of energy. So that will be equal to mu mg x. You lose mu mg from both the sides and you get x equal to h cot theta. H is known to you too. Cot theta, you know, cot theta, cot 30 degree, cot of 30 degree. Now, tan 30 degrees 1 by root 3, so this will be equal to 2 root 3. 2 root 3, if you solve, you get roughly 3.5 meter. And now if you place this value of x and substitute in this equation, h is given to you. What is h? H is 2. H is 2. So h here is 2 minus mu into, take it that side, you get mu into 2 root 3, and then that term also will come there, mu into the point you calculated here, that is 2 root 3, right? 2 root 3 here, 2 root 3 here. Besides, you have h term 2 cot 30. So this will be 2 root 3 mu, fine, to mu x, x is equal to 2 root 3. This is equal to 2. So you lose 2 from here, 2 from here, and 2 from here. And then you get mu equal to 1 by 2 root 3. Root 3, take mu common, 2 root 3. So that will be equal to 1 divided by 2 into 1.732 or 1.762, whatever. Okay, if you solve this, you get the value of mu. You see 3.5 meter, if you look at the data, 3.5 meter is coming in two problems with 0.29. This value will be corresponding to 0.29, roughly 2 divided by this. So the correct answer for this will be 2. Correct answer is 2. Solve these terms, you get the correct answer. All right.